So Assalamu alaikum. I think we can start. Meanwhile, people will be joining in. So welcome to Data Science and Future webinar powered by Transformatics. Thank you very much for taking out time specifically over the weekend. I'm sure these 90 minutes will be fruitful for all of us. And let's make sure that we collectively get as many takeaways as possible. So I would like to hand over the mic to Mr. Faraz Said. He's the experienced data scientist and currently working in North Bay, Teradata, and he has a great experience across the industry in terms of data science. So over to you, Faraz.
Let's just start with this visual that you can see. And there are lots of plots. So this is the design of the aircraft which was used in World War II from the Allies. So they started plotting the areas which were more damaged during the battles, and they started to plan that they should put a heavy armor on these places so that they cannot take further damages. But on the other end, there was other analysis based on this data that is there any possibility that the reason, sorry, that the reason these aircrafts came back to the base just because that they survived these bullets, and those aircrafts which took the bullets on the non-marked area didn't came back. So that's a different mindset, or you have the data and you build another insight which was lying behind this data or in the hindsight. So based on that, they started putting armor or strengthening the places which were not marked in this picture. So this is how you can use the data, whether which is visible to you or which is in the hindsight, but you need to make sense out of it. Moving on, the agenda for today's discussion or the webinar is what data scientists do actually. Is data science a new or an old field? What are the key drivers that are overall data science demand is taking place, the data science around you, what you are experiencing in your daily life, how data science is shaping the future, what is Industry 4.0, we'll get to this in detail. Then what is the difference between the industry and the academia? What sort of initiatives could be taken to bridge this gap? And what sort of battle gear is required to become a data scientist? So briefly, data science is about turning the data into decision using machine learning. That's the simplest way we can put into different fields, artificial intelligence, machine learning, or deep learning. And this, using all these tools or the skill set, we can use the field of data science or to drive the insights from the data. So the first question is that what data science do? So we are more focusing towards the role that the data scientists play in the current world, or what sort of a role they can have in future, and how help industries to grow. So these are the more or less 8 domains in which they can help to grow the business, empower the management of the offices, and to make better decisions, directing the actions based on the trends, which in turn help the identifying the goals of the organization, challenging the staff to adopt best practices and focus on the issues that matters, identification and refining of the target audiences, identifying the overall opportunities that the business can take, decision making with the quantifiable data-driven insights, and testing these decisions. So I think people who are in this call who are related to the professional life, they can relate to that most of the tasks they are doing in their daily operations. But the point is that how data science help to make these decisions or make these operations helpful to grow and the business overall. Okay, so data science, it's a new field and our old field. So it's a buzzword, as Numan has mentioned. So back in 2008 or 9, people started to look after these job roles. What should data scientists do? What sort of skill set is required? So what I want to mention over here is that data science is pretty old, and it is new in terms of like Columbus reaches to the new world. So Columbus did reach to New America, but that land already existed. Similarly, data science already existed, but in today's world, with all the high-tech computing available, and the importance of how we can put data in a shape that we can make better decision, comes up with the word data science in today's world. So overall, the story of data science goes back in 60s, I would say, but in today's world, the data science is basically coupling of a mature discipline of statistics and very young computer science, we can say. We have the data, we can use the data, we have the statistician in the past, but now with the high compute power, we can process that data and we can come up with the insights that can help us to grow. So just a brief overview of the timeline that we have for the data science from 1962 onwards. There were different events that were happening, different workshops were being carried out just to make sure that all the data that is being captured or data that is being used can help to overall benefit the businesses or the society. So in this manner, from the 2000s and onward, the word data science came into being in a way that it became a hype. And from 2012 onwards, the data scientists lived heavily ever after because there was a lot of data, and based on this data, the companies make fortune, and there onwards, the demand of the data scientists did increase. So what are the key drivers of the data science demand? This is a statement from the LinkedIn co-founder, Ann Blue. So data scientists are almost already employed because they are so much in demand. So as I mentioned, the role about the data scientists, what they do, most of the professionals are doing the same thing, but they don't know, and they can improvise their overall decisions using the data or leveraging the overall data that they have. The other thing is IoT. In today's world, everything is connected: smartphones, smart homes, cars, then the wearable devices. So these are the things which are constituting or generating a lot of data. Based on this, we can analyze the behavior or the pattern of the people and what sort of needs they do have. We can analyze the overall lifestyle and what sort of comfort can be further provided. So if the smartwatches is one of the common examples that people are more into it. They are tracking their health, the overall exercise or the workout that they have, and what they need to do. So how they came up with the idea to build this wearable device, because they understood the overall requirement of the people, that they are more concerned about their health, and now they want to track it. So these wearable devices can help them to do so. So this is how the data is generated. So we did a project recently in which we actually predicted the sleep pattern of the people based on the wristwatches or the smartwatches that they had. And we were able to understand that what sort of overall lifestyle can lead to different type of sleep patterns. So these sort of analysis or the research are taking place based on the data that is available via IoT. The next is that the decision making. So once we have the data, so what gives us the benefit of the data? I can put it in that way, that if I have the overall information, the insights that are driven from the data that a particular company has collected from their customers or the sales or the purchase of the stocks. So based on that, they can come up with a decision. They can make the decision based on the predictive analytics. So that will help in overall decision making of the organizations or the management. So data scientist role is in demand from the corporate aspect or the organizational aspect in a way that they can help to make some strategic decisions at the organization level. So moving on. So how data science is shaping future. So when we talk about futures, then there are different processes which are in place, which are already working, but they are improvising. And based on those improvisations, they are making some decisions. They are coming up with different strategies or the approaches which can benefit the overall mankind or the organizations. Or in short, we can say that they can add value to our daily routine. So overall, if you can say these are the tools or the domains which are overall contributing towards the field of data science, and it can help to challenge the increasing demand in different walks of life and sustainability while ensuring the best solutions. At the moving on, uh, analytics at the agriculture level. So that is something new for Pakistan, at least. But people are making most out of the data that they are gathering from the agriculture sector, and how they can enhance the overall production or the augmented analytics. So this is something which I would say is that going to take the future. The analytics or the decisions or the recommendation that are part of the from the analytics, they will be augmented with the overall processes of the organization. The management can take decisions within a few seconds based on the information or the data that is available. And definitely it depends upon the what sort of information is being shaped, what sort of models are being developed, and based on that the decision making can be made. So currently in most of the organizations, the data science is being used for the strategic perspective, but here I would say that in near future it will be taken over by the tactical decisions also. So healthcare analytics is something that I've mentioned earlier. So few of the projects that we have done in the past. So the wearable devices, the smartwatches. Recently, I have read a case that where the smartwatch saved the life of a person who was wearing it because the heartbeat dropped, and that message was sent to the uh, medical authorities, and where they were able to reach out to the person in time. So that is something which is pretty fascinating from the healthcare side. Then there was sleep prediction that I mentioned earlier. Then genomic sequencing to analyze the overall genes of a particular person. That was pretty high intensity sort of work was required for that. But now with the availability of high computing and massive data, that activity or that sort of information is readily available to doctors. Then the cancer detection is one of the use cases which is taught to the students of data science who are learning or who are stepping their first step, taking first step in this particular field. Vision analytics is something which is totally new for Pakistan at least, but face recognition or the customer analytics, the transport sector, manufacturing, anomaly detection, or the public and workplace safety. For all these, the video feed can help you to analyze the overall the events that are happening and what sort of actions that need to be taken. So face recognition is something that we have seen in the movies that the intelligence agencies are trying to find out someone, and they have the image and they are tracking different visual feeds. So that is actually happening now. Then overall, if we can say about the transport sector, so the video feed can let the transport authorities that what sort of congestion is going to happen, what sort of safety measures need to be taken, and what sort of future steps need to be taken to avoid such sort of disasters. So these are the roles that vision analytics can take. There are multiple applications of it, but I can mention few over here. Then moving on, the industrial analytics. This is something new for the world, at least I would say. The hype is over for the industry 4.0, I would say, but it is prevailing. It is the connected factories, smart factories are there. Industrial IoT is there. So valued 13.60 billion in 2020, 36.73 billion by 2026. So this is something which can take the world in future, and the data scientists can play their role in different aspects of this industrial analytics. From this particular domain, I would hand over to Bilal bin Munir, who will shed some light over the industrial analytics. And the main purpose to focus on industrial analytics is that there are further domains which use the application of data science. And overall, this umbrella will cover the future of the industrial analytics. So I'll hand over to Bilal bin Munir. Over to you, Bilal, please.
Thank you, Frost. Assalamu alaikum, everyone. Hello, everybody. So taking on from Frost, let's talk about the Industry 4.0. Uh, so this is sometime back in 2006 to between 2010 in Germany. This fourth industrial revolution term was coined. Germans are way ahead in their manufacturing industry, and they started using the robotics, artificial intelligence, and they start calling it fourth industrial revolution. In 2016, during the World Economic Forum in Switzerland, one of the German Dr. Schwab, he coined this term, Industry 4.0. So Industry 4.0 it is not just one, it is not the manufacturing part of the whole ecosystem. It is set of, it's a combination of uh, the manufacturing industry, the factory, the suppliers, and the consumer. And it talks about all the whole ecosystem and how the whole ecosystem is connected, and what technologies it will use and how it will shape our lives going forward. This, you can say, is the inflection point. And now we must be prepared, and we must learn that uh, from this point onward, the way we live our lives, it will change. It has changed a lot. When we use the computer technology, we see the media, the social media we use, but it has changed. It will change the way we interact with the businesses, the way we use the products that we use, and how those products are made. So it will change our lifestyles. And if we are not aware of it, if we do not know what is happening, we will not be able to catch it up. So industry is 4.0. It's about revolutionizing how the manufacturing industry will work, how it is working in some countries, and some other countries are not they're not really catching up. Some countries are behind. So let's see how things will work. And the IoT, the cloud, the robotics, all these things you hear very often. But as we move forward, we see how all these technologies are going to connect. Let's see how this journey started. We started off with the steam engine in 1784. Before that, everything was done manually. People were making, let's say, guns or any equipment. One man was making a whole equipment. And then came the steam engine and the water-driven engines, the looms, the floor mills, and many other machinery started using steam power. That enabled people to make different parts in different factory, and then they can assemble it, and it started increasing the production. So that was the first industrial revolution. Those 8-hour shifts came into being, and then people, the production enhanced, and those steam powered engine in the ships and in the locomotive enabled those products to go distance from localized. They start moving into the other countries or other cities. That was the first part. It happened in 1784. It started in 1784. Almost 100 years, the industry 2.0 came up. That changed the industry completely by introducing the electricity and the internal combustion engine. So that actually sped up the production power. The production increases a lot. The accuracy increased a lot. Machines were made. They now those machines were actually exported, and then products were made in a very accurate, much better quality, much reliable. And then this industry 2.0 really actually shook up the world. Then, if you look at this, approximately 100 years later, in 1950s or 1960s, when PLC, which we call programmable logical controllers, they came in, and they start automating the machine. So you can feed the machine with the instruction in that PLC, and it can repeatedly do the same thing again and again, and it can increase the production and can keep the quality. So industry 3.0 continued till early 2000s, when more CNC machines, which using computers, started making things much better quality, very high production levels, less human interaction, uh, and it continued till this industry 4.0 really started in 2010s or 2015s. So what is the difference between those automated machine and computer driven machine industry and this cyber physical systems and internet of things and industry 4.0, how it is different? So let's look at let me try to give you example of Tesla. So Tesla is it's a car, it's a electric vehicle. Uh, it has GPS, it has computer sensors everywhere. So what happens? You're running a Tesla, and Tesla is monitoring your car. So the services they give you are as such. So your car is running, and they see that you're driving in an area where your brakes are wearing out more quickly. Those sensors from Tesla will send the data to the Tesla company. They will see when your brake pads are going to wear out, and their system will connect to their suppliers, order in advance your brake pads, and then Tesla will connect to you and ask you to bring the car to Tesla workshop or the dealership, and parts would already be there. Your parts, before they make any trouble in your car, it will be replaced well in time. So this kind of predictive maintenance is only possible if your whole ecosystem is connected. So parts are being made at a supplier, and if the whole ecosystem, the whole chain is active, so when your parts are wearing out quickly, the order at the supplier end will be placed, and supplier's machinery, which is already connected to the whole ecosystem, will start producing the right model of the brake, that can be ordered and put it in your car. So this is one example. Let me try to give you another example. Let's say you order a shoe on the website, and you go and you pick a specific size. So you have a special need, you normal routine sizes does not fit your foot. So you can order a special uh, made for yourself exact size for your shoe, exact color you want, and from that website that order will directly go to the machine, and machine can then order the raw material that is required and make a shoe of exact size as you want. So this is what is happening already in some countries, and those companies which are not following it, or those factories which are not following it, they're not gonna survive in the future. So when we look at this kind of ecosystem, then we see how it will do. It will lay off many people. In Germany, they analyze that these industry 4.0 will cause 600,000 jobs to be laid off, which is a very high number. And it is better of concern for many people that how what will happen if the machine takes over from the human being. But there's another analysis that when this industry will move to 4.0, it will require around 1 million jobs for software engineers, data scientists, people who are acquainted with the machinery, who can do the maintenance for this kind of machinery, network, cybersecurity, and so on and so forth. And then the problem comes in that not everybody who is currently working has the knowledge of those softwares or is not that technical. So again, that what Faraz was telling you initially, the AI, the machine learning, it will enable you to actually run and fix and maintain these machineries. So there are already factories in Germany, especially in Germany. Germany is quite advanced, and in America as well. So you wear your AI goggles and you go to the machinery, and your AI will teach you and guide you how to fix that equipment. It will guide you, and when you look at it, it will guide you, and you can make those follow those instructions, and you without being any really technically trained or graduated in some software engineering degree, you can fix those things. So but we need to adapt to it, and what we need to do is to see from end-to-end perspective. If we look at the can we go back one slide back? So if the slides are changed, you can see there are so many technologies, and you can't expect one person to be master of all these technologies. So if we think that one fine day we will build a factory, and we say it is a connected factory, it complies with the all 4.0 um, parameters, but it will not be. It will be a journey. It will be a journey for a manufacturing industry and for a whole ecosystem. And to build the whole ecosystem, we would require so many data scientists, engineers, people who can do business analytics. We know there are people from the banking sector. So when you are setting up such an industry, it will be connected with the banking system, where the payments will be, transaction will be done. When you order to supplier, there will be a cost. That transaction will go through a bank. When consumer will buy something, when you buy your cloud computing from Amazon or Azure or elsewhere, you will be paying them. They will be charging you. So banking will be there, cyber security will be there. There will be companies providing internet. There will be company making machinery, and so on and so on. So that ecosystem has to be built uh, in and around that manufacturing industry. And to build that ecosystem, there's a need that we as a society, we need to move ourselves from the status quo, and move ourselves from the conventional way of doing things to the next level. uh, you must have heard the word smart factories. So the examples I've given of Tesla or the German factories, these are the smart factories where there will be less human interaction, much more interaction with machinery. It will give us more accurate and more higher, better quality products. So there's a bunch of technologies that will take this industry from 3.0 to 4.0, and it will take some time. It will not be one fine day over the night thing that you can set up an industry which we can 4.0. Can you move forward? So data sits in the core of these smart factories or this industry 4.0 revolution. We would not be able to reach this point of inflection if we did not have this much data. Again, coming back to Tesla, when we look at the Tesla's autonomous driving, why Tesla's autonomous driving is one of the best in the world, because they have billions of miles of data from all those sensors in one car. And from there, they learn how the car behaves. And from there, they are continuously using that data in their new production. So every day there is improvement in their newer car and in their newer models, and they are continuously improving their vehicles and continuously improving their reliability, and giving a better service to the customer. So this data collection is one part, and then analyzing that data is another part. So when we talk about the data scientist role here, data scientists are going to become the most important people, or most required people in the industry, not just in the banking or IT or technology company, but in the manufacturing industry. So we must see that how we can shape ourselves, and how can we equip ourselves to be able to work in this future of manufacturing industry or any other industry for that matter, retail or banking. Faraz mentioned so many industries that where data science can be used. So digital company, nowadays you must have heard many companies, they call themselves their digital company. If you look at the telcos, if you go back in early 90s or early 2000, they were providing you two services, SMS and then phone calls. Now you can use Jazz, you phone Telenor, and you can make you can do money transactions. You can have your data stored, you can have WhatsApp, you have so many other options available to you. And this is, each company is moving towards a digital company. uh, those website where you can only view things, now you can buy things, you can trade things. They are giving you finance options, so on. So digitalization is one of the most important component of industry 4.0. And then collection of data. If we when we talk about the 4.0 industry, let me give you another example. Schlumberger, they have their huge machinery which is used for the oil drilling. Now they are using very uh, big pistons and drilling machines, and they are using hundreds and thousands of sensors on those machineries: vibration sensor, temperature sensors, oil flow, water flow, electricity transmission. So many things are running at the moment uh, consecutively. So when we what happens normally, that machine has an increased vibration because there was a problem in the one of the component, or the let's say the electricity flow was not correct because one of the transformers was not producing electricity correctly, and that produced a vibration and the machine broke down. Once the machine breaks down, the whole rig will be stopped, the part will be brought in, it will be changed, you run it again, and guess what, because the problem was in the transformer and it gave surges of electricity, the new part will break down again in some time. So when so many things are happening together, and if you can collect data from all those sensors into, let's say, your do big uh, data warehouse, or it can run the analysis on the runtime, and then it can tell that, let's say, this is where the problem is, the electricity is not flowing correctly, and that's causing the vibration, and you can stop and fix the transformer, and then you can you will not have those disruptions. So that has to be harmonized and integrated. And to make a timely part change, your supplier of the transformer, or maybe that drill, they should be integrated. And if there's a problem, if the part broken down, that machine can actually, using the internet, place an order to the supplier, and supplier can bring in that part well in time. So those collaborative efforts needs to be done. When we look at the end-to-end supply chain, from the supplier and to the consumer, and maybe the suppliers of the suppliers, and those manufacturing industries, or those companies who will invest in their suppliers and make sure that their suppliers have those integrated system with their manufacturing plant, they will be the one who will be uh, running and making a difference in the future. If we continue to work the way we are working, we think that we have a machine which has automation, it's a CNC machine which has a good computerized system, and we can feed in few uh, patterns and we can run that. It will not help. This is not going to work for us. And those companies who think that we don't really need a data scientist and we don't really need those people who can do the analytics and run the analytics, they're not gonna survive in the future. So we must think that we need to uh, enable ourselves, equip ourselves for this new era, because it has, as Faraz mentioned, it has passed that hype stage. It is now a reality, and we must admit to it. Can you move to the next slide? So yes, it has passed the hype stage. We need to rally our organization. So if you're working for the banking, manufacturing, retail, IT company, you must start talking about it. Be the leader in the change. If you are in a position where you can make the change, you must start doing it. And the best way to do it is to learn and know what analytics is, what data science is, and how can you use it. And we must not worry that uh, we we should know the programming side of it, we should know the statistics or those algorithms or those models. It is not required to ask a intelligent or educated question. What is required that you should know uh, that what right question you are able to ask to the data that you have, or to the people who are maintaining your data. And that's this effort, that this webinar is all about this, that we must make people aware what data science is, what industry 4.0 is, because what we hear, when we talk to the people, they're really for them it is shrouded into some kind of a mystic fog, that what's analytics, and not for us, it is for some thing like Tesla or something like NASA only, then you need to use it. But it's everywhere, it's around us. And innovation is not just that you need to come up with a new machine or some new code or some new iPhone model, but it is about simply improving a process, making a process useful, easy, uh, maybe automating a process. That's another type of innovation. Scaling up. So what we do, we don't scale up our operations. We reach a level which is satisfactory to us, but then we don't go beyond that. So whatever you are doing in your organization, in your own business, try to scale up things. These technologies, this computing power available to you this day is uh, uh, is going to enable you to scale up to the levels that you cannot imagine. If we can sit here uh, in our rooms, and we can teach and learn and do things to somebody sitting in USA or sitting in Malaysia or Indonesia, thousands of kilometers away from us. So it means our reach uh, is it has we can reach anywhere. It's beyond the borders now. So we can scale up, uh, and we must try to scale up. And to do that, we must begin the journey now. We must think that our ecosystem has to be aligned with the world, and we must learn those technologies where we can uh, take ourselves, our society to another level. So that's all from my side. I think we can open the floor for the questions.
So moving on, now there is a gap that has been observed, at least by me and few of the people in my community, that the students who are graduating from the university, they are learning machine learning or some aspects of data science, maybe statistics or AI, some basic courses. But this do struggle in the industry or to penetrate in this industry. Why is that so? So there could be a different point of view from the different people, have different mindset. But what I have gathered so far is that I'm going to present to you. So first is the level in advancement in machine learning and AI. So usually the universities are teaching the textbooks that are recommended by the academia or some curriculum is designed. But the industry is expanding. They are going on a pace which is required or which is demanded by the market. So they don't get their hands on to the overall market experience or what sort of real-time business problems are there. We do have certain use cases that are taught in the industry, in the universities, but things have changed rapidly. Business cases have changed rapidly, and the business problems are coming to the in a way that they need to be addressed at a pace where they cannot have an impact. The other thing is that how important is a research problem to you? For a student, the mindset could be that he wants to or step into the domain of data science or artificial intelligence or analytics, or to get good grades to graduate from the university, and based on those grades apply for a job. But from the industry perspective, the problem is sometimes it can impact the whole business or can cost you a lot. For example, if there is a problem that has occurred in a telecom industry where there is a service interruption, if they cannot resolve it, they can lose the subscriber base. But on the other end, when the students are researching over it, they can gain their experience, they can gain the knowledge from the use cases that the industries have pitched or published to the academia. But at that time, they cannot realize the overall importance, that what sort of impact or what sort of hit or the cost can be paid by the companies based on those problems. Again, the third point is what is the impact means to you. So for me, if I am addressing or I'm designing some predictive model or analytical model for a customer, the customer has trusted me to save the business or to address a business problem which is causing a lot. But for a student, it could be something related to academic mindset only. Then the industry is shifting on a drastic pace, as Bilal has mentioned about the Industry 4.0, that it's a huge umbrella under which there are multiple domains and everybody has to pick or make their place in a particular domain. Then overall academia, they are learning a lot of different courses in the curriculum. Machine learning or data science could be one course, especially at the graduation level, undergrad level, let's say. So then they come the masters in the specialization in a particular field. So these are the things that I believe which is causing a gap between the industry and academia. And then what sort of steps that need to be taken to bridge this? Let me just tell you that what I think about how we can bridge this gap. The first thing is that recently I have come across few companies who have started their graduate programs in which they take the fresh graduates from the universities, they put them on a training program or sort of internship for 6 months or maybe 11 months. They train them, they use them in the different teams that they are working with, different customers they are pitched to. They do understand the real world problems, and then they are then move forward to the permanent jobs. And that's how they start their journey. So that is one thing that the organization have taken. The other thing is that what I believe that the universities should collaborate with the corporates or the companies or the professional setups. The final year project should be evaluated by the organizations. The company should collaborate with certain organization. The students should go to them particular organization, understand their problem, and they should start working or design their final project overall approach based on the real world problem. And the organizations can verify or validate the overall solution and how it has benefited. That's how the students who are graduating from the universities can get their hands-on experience on the live data or the real world problem. And on the other end, the companies or the organizations, corporates can utilize some good talent from the universities based on which they can have a better future in this particular domain. That's my take on it. But again, based on these thoughts, it could be wrong, it could be right, depends on the scenarios and the approaches that the companies follow.
So I think that's it from our side. So thank you very much, Bilal, Faraz, and the audience. So I think